Hi there. Today I want to discuss the IGCSE organic chemistry, taking you through all the main essential aspects as per the syllabus is concerned. So what I will be doing today is taking you through each and every functional group that is present in as per the present syllabus, starting from alkanes, alkenes, alcohols, and let's go through some essential chemical reactions which will help you to boost confidence as to how to tackle those questions in the examinations. First of all, I would like to start with the general reactions of alkanes. Now, the alkane family, they have a general formula CnH2n plus 2, where n is the number of the carbon atoms, and for example, if n equals to 4, you could just substitute and say this is C4H, 2 times 4, 8, 8 plus 2, 10. That's basically how you get to the molecular formula of various alkanes. So alkane has some typical reactions as per the syllabus. They have 3 of them which you have to understand and you have to practice. The first of them is called combustion reaction of alkane. So let's have a look at a few combustion equations. We are talking of complete combustion. Now remember, any hydrocarbon, when it undergoes complete combustion, it produces carbon dioxide and water. Now let's pick up the first few alkanes. Don't forget, the first few alkanes could be, you should practice the molecular formula by substituting the value of n from 1 to 4. So let's starting off with n equals to 1. That would give us methane, CH4. N equals to 2 will give us ethane, C2H6. So if I do complete combustion of methane, as we agreed earlier, we will get CO2 plus H2O. But then most of the students usually don't have problem with the equation. The problem comes in balancing the equation. Now thankfully there are some easy tricks that you could use to balance these equations quickly and efficiently in a very short period of time. Just check the number of carbon here. Because there is 1 carbon, so we just leave it as it is. Because we see there are 4 hydrogens, just divide this by 2 and write that answer here. Now add up all the oxygen on your right. I have 2 oxygen there and 2 oxygen there. That's 4. Divide that number by 2 and whatever answer you get, write it here. Why don't you try to balance this equation using the same way? Pause the video for a while, balance the equation, and then check back with my video, see whether the answers were correct or not. Well, hopefully you tried. Let's have a look at these answers. Because I see 2 carbons, so I'm going to put here 2. Because I see 6 hydrogen, so I'm going to put here 3. Add up my oxygens on my right. I have 2 times 2, which is 4. 4 plus 3, 7. 7 divided by 2 is 3.5. This equation is perfectly fine, but in case you want to get rid of the decimal, just multiply the entire equation by 2. In that situation, this becomes 2, this becomes 7, this becomes 4, and that becomes 6. So why don't you now try to do combustion equation of the next 3 or 4 alkanes? Propane, butane, pentane. Try to do complete combustion equations with them. Now I'm starting off with the second reaction of alkane, which is called cracking equation. Now, cracking, this is a very, very important industrial application what we have. Because when you do cracking of alkanes, we get a mixture of alkanes, alkenes and hydrogen, and they're all very useful products. Large alkanes have a limitation in their usage. They cannot be used as fuels easily. So when you break alkane down into smaller bits, smaller alkanes are good as fuels, smaller alkenes are used to make plastics, and of course hydrogen, also a very good fuel. So when you want to do the cracking of alkane, remember the conditions are 500 degrees Celsius, and they also need certain catalyst called zeolite. You could also work with catalyst such as aluminum oxide. Also, high pressure is recommended. So 500 degrees Celsius temperature, high pressure, catalyst such as zeolite or aluminum oxide. Now, to carry out a chemical reaction to represent cracking, This is very, very simple because the marking scheme has no answer for it. As long as you could balance the equation and as long as your products are smaller than the reactant. For example, if I give you C8H18, how would you name this alkane? 8 carbon, so that's oct. And alkane, the name ends with ane, so this is octane. So when you want to crack octane, remember you can get a combination of products. All the products on this side should add together to give you this. So it doesn't matter what products you can write here. For example, let's say I want a combination of an alkene and alkane. Sometimes in examinations, in past papers, I have seen questions where the examiner says, well, I want alkene propene. They even give you the formula of it. And then they'll say, okay, what do you think could be the other product that you will get? Well, all you have to do is subtract this from here. I have 8 carbons, subtract 3, so that gives me 5 carbons. From 18 hydrogens, subtract 6, that gives me 12 hydrogen. That's pentane. This question can be asked in different ways. For example, if the examiner says, I want C4H10, what else could be a product? Well, in that situation, there's 8 carbons, there are 4 carbons here, subtract them, that gives you C4. From 18 hydrogen, subtract 10, that gives you 8. Why don't you try to name them? 4 carbons, that is bute, and because it's more than the double of 8, so it's ane, butane. 4 carbon, this is bute, but this is exactly double of 4, so it's ene, so butane and butene. So why don't you practice with C10H22, try to give different combinations. In fact, why don't you try this as a question? C10H22 and C10H22. This time I want you to take out 2 things. One of them should be hydrogen. So what else do you think should come here? Easy answers. You could subtract this from here. So you might get C10H20. Just remove 2 from there. Or you could divide this by 2. So it will become C5H10. But then be careful. You need to balance this equation. Because you divided this by 2, so if you just put here 2, the equation is balanced. So you see, you could do various combinations here. As long as this all adds up to this one, you're fine. Now, the third reaction shown by alkanes is called substitution reaction. Substitution reaction. In your advanced classes in AS level, you will actually study this reaction as a free radical substitution reaction. Now this reaction is between alkanes such as CH4 and molecules such as chlorine. Now what happens is this reaction takes place in the presence of light. And in this reaction, as per the IGCSE level, all you have to remember is one of the H atoms from the alkane is replaced by a chlorine atom. So one H goes out, one chlorine comes in. So one chlorine comes in, one H is out. So you get CH3Cl. Now remember the H which comes out and the Cl which is left here combines to form HCl. So this is chloromethane. And this is hydrogen chloride gas. If I continue this reaction, all these H's one by one can replace. In your AS classes, you will study the complete mechanism of how this reaction actually happens in air. So, as a matter of practice, why don't you try this reaction? C2H6 with bromine, exactly the same way. Why don't you pause the video for a minute, try to complete the equation and then check back with my video. Well, if you have tried, remember one Br has to come, one H has to go. So C2 H5Br, and that H which came out and the Br which is left will combine to form HBr. This is bromoethane and this is hydrogen bromide. So that's the three reactions shown by alkane. Now let's have a look at another set of homologous series, alkenes. Alkenes are hydrocarbons and they have a general formula CnH2n. They're basically called unsaturated hydrocarbons. They usually have a double bond between carbon and carbon. They can have more than one double bond, but at least one should be there. Now, in the IGCSE syllabus, one of the main reactions shown by alkene is called addition reactions. In your AS classes next year, you will study this reaction as electrophilic addition. But as of now, you only learn the name addition reactions. Very, very simple reaction. In this one, what basically happens is the double bond is going to break, and that will change into a single bond. That's it. Let's have a look. Let's have a look at a molecule called ethene. Now, eth basically means two, so I have two carbons. There's a double bond there, and each carbon, must have four bonds. So I'm going to put two H's on this one. That's 1, 2, 3, 4, and two H's on this one. So that's basically it's the structure of ethene. Now, when we do addition reaction with ethene, for example, I want to add hydrogen to it. Now, some addition reaction needs some special conditions, otherwise they will not take place. The addition of hydrogen needs a special catalyst, nickel. It also needs heat, about 100 degrees Celsius. So when you do addition reaction, what is important is one H will come to this carbon and one will go to that carbon. So you see here, the carbon already has two bonds, two hydrogens, and this carbon also has two hydrogens. Now, it initially had a double bond between them, but now, since one H is coming here and the other H is coming here, this double bond is broken away and it changes into a single bond. Don't forget, carbon can only have four bonds around it. So this is now ethane. Ethane is a saturated hydrocarbon. Ethene is unsaturated. So your unsaturated hydrocarbon has become saturated. Addition of hydrogen, also called as hydrogenation. Exactly on the same line, you could add different things to alkenes. For example, you could add chlorine. Now let's say what happens when you add chlorine. Exactly the same thing, but no special conditions required at this stage. Don't forget, if you add chlorine to hydrocarbon in the presence of light, it's called substitution reaction. But now you're adding chlorine directly to alkene. That's an addition reaction. So as we said earlier, one chlorine should come here, the other one should come here. So the carbon has two H's, this carbon has two H's. Don't forget, the double bond will become single bond because one chlorine each will come on these carbons. Now when you try to name this, remember there are two chlorines, and this is carbon number 1, that's carbon number 2. So you could say this is 1,2-dichloroethane. 1,2-dichloro because there are two chlorines, eth because there is two carbon, ane because it's single bond. So 1,2-dichloroethane. But the IGCSE marking schemes will give you full marks even if you just say dichloroethane. But it's recommended that you give the position. That's reaction with chlorine. So as a practice, why don't you do the reaction with bromine and HBr yourself. You could do these reactions. The reaction will be exactly the same. You put one Br here, one Br here, or when you react with HBr, one H here, one Br here, exactly the same thing. Interestingly, there's one very, very important reaction involving ethene and steam. This is actually the industrial preparation of ethanol. This is basically preparation of ethanol when you react this with steam. Now steam is H2O gas. It needs 300 degrees Celsius, 60 atmosphere pressure, and you need H3PO4 as catalyst. Or any acid would do, but that's usually the recommended acid. Now when you react steam under these conditions, now remember steam, H2O, is best understood if you just use it as HOH. So you could do the same, just give H to this one and give OH to this one. So as usual, carbon has two H's initially, one more H comes in, the double bond will change to single, two H's remain, OH comes in here. This compound, as you see, it has OH, that means it's an alcohol. Since there are two carbons, so I'm going to call it ethanol. So this is ethanol. That's basically how ethanol is manufactured. This is a good examination question for you to memorize. So that's the addition reaction with ethene. Now, as a practice questions, why don't you do some addition reactions with propene? Propene has three carbons. You could put the double bond here or here, it doesn't matter. I'm going to put it here. So this carbon has one H, second H, remember 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. There you go. That's propene. So as a practice question, why don't you try H2 and HCl and steam to propene. So I'll give you a minute. Why don't you pause the video, solve the question, and then see what your final answers are. Well, if you have already finished the question, this is what your answers should have been. With hydrogen, you should have got one H here, one H here. This was your answer with hydrogen. The second question I think was with HCl. With HCl, if you're going to react this with HCl, remember you could put H here or Cl here, or you could put H here or Cl here. But again, in your senior classes, you will study some more additional rules, something called as Markovnikov rule. As of now, just stick with the fact that you could put the H here, the one who already has more H. So the Cl could go to this carbon. So I'm going to put the H on this one and Cl on this one. So I get 2-chloropropane. Remember, if I had put the chlorine here, I would have got 1-chloropropane. And if you had done the reaction with steam, it's the same situation. Instead of Cl, you would have got OH here, and that would be propane 2-ol. That's because the position of OH is at second position, so it's propane 2-ol. That's how we name it. But if by any chance you put the OH here and H here, in that situation it would become propane 1-ol or simply propanol. So that's the addition reactions of alkenes. Alkenes also show something called as addition polymerization reactions. They're very useful for industry. We get a lot of plastics from that. For example, something called as addition polymerization of ethene. So what this means is you will take n molecules of ethene, n could be any number, it's usually about 10,000 and above, it could be any number, and you polymerize ethene. The trick is, just understand that the double bond between carbons will change to single bond, and that's basically what you do. Just put the brackets and put the empty bonds here. These H's which are on the carbon, they don't change, so you put the H's as it is. And this is basically called the monomer. Mono means one, mer means unit, so that's 1 unit. And this basically is called polymer. This is something made up of many units, and that's the repeat unit. Sometimes exam questions would say, draw 2 repeat units. You just basically draw this 2 times. So that's this monomer is called ethene, and this is called poly, and put the bracket and just put this word inside, so it becomes polyethene. You don't say it's polyethane, although there's a single bond there, but you say polyethene. That's basically you're trying to say it's a polymer of ethene. This is used to make plastic bags. So that's the polymer that you get from ethene. So let's have a look at the polymer you get from propene. Now if you look at propene, propene has, as we said, 3 carbons. So I have 2 H's here, 1 H here, and 3 H's here. So let's say I want to make polymer of propene. Again, the trick is to just draw 2 carbons in. That's always the structure of a polymer. The 2 carbons that you see here are these 2 carbons. So this carbon has 2 H's, so put 1 here and 1 here. And this carbon there has an H and a CH3, so H and a CH3. So this is propene. Now if this is propene, this becomes polypropene. So that's polypropene. This is used for packaging, it's used to make plastic cups. So very useful plastic. There's another very, very important polymer that we get. This polymer is called Pvc Polyvinyl Chloride. This is made from the monomer. Why don't you try to name this monomer? It has 2 carbon, that's ethene definitely, that's chloroethene. This is chloroethene is the monomer. This is also called as vinyl chloride. So that's the monomer there, and if I want to make this into a polymer, so that's basically what we do. Just copy it as it is, just draw this out. Remember the 2 H's stays as it is. This H and the Cl stays as it is. The only difference now, the double bond has changed to single and we have these extensions. This is very popularly called as PVC, polyvinyl chloride. In fact, the board on which I'm writing is a PVC. It's also used for electrical insulation, it's for making water pipes. At homes, you will see this quite often. So these are some of the examples of polymers that you get from alkenes. Other important polymers include something called as Teflon. Teflon is a non-stick. We use Teflon to make non-stick cooking utensils. You might have heard of the word Tefal. There's a company who makes this kind of saucepans. This is the monomer of Teflon. Try to give me the name of this monomer. It has 2 carbons and it has 4 fluorine. This is tetra. Tetra means 4. Tetrafluoroethene. Tetrafluoroethene. Now, if I make this into a polymer, all I have to do, remove this. There you go. This is the polymer, and this is called Teflon. Teflon is used to make non-stick fry pans. This is basically a plastic which can, it's a very, very high heat resistant ability, and it does not stick to the food. So that's the general reaction shown by alkenes. I'm going to take some reactions of alcohols now to finish my video presentation. So, alcohols. But before we move on to alcohols, a quick review of what we've done so far. Remember, we did alkanes, we did combustion of alkane, cracking of alkane, substitution reaction. In alkenes, we did some addition reactions, and we also did some addition polymerization. And we're going to have a look at what alcohols can do. The reactions shown by alcohol, starting with, before we begin, let's have a look at the general formula, CnH2n plus 1 OH. That's basically what alcohols are. And some examples of alcohols, for example, N equals to 1, that would be CH2 into 1, 2 plus 1, 3 OH. Since it's only 1 carbon, so we say methanol. That's, if it's N equals to 2, just put the value in, that's C2, 2 into 2, 4, 4 plus 1, 5 OH, because there are 2 carbon, so we say ethane, and we just put all, ethanol. So why don't you try for N equals to 3 and 4 and have some practice there. Let's have a look at the first reaction of alcohol. Of course, being an alcohol, it's highly combustible, so let's have a look at the combustion equation. When you burn alcohol, they burn very easily, they burn with a blue flame. So I'm going to ask you to burn 2 alcohols there. Okay, so as hydrocarbons, when you burn alcohol, you still get CO2 and H2O, so you still get CO2 and H2O there. Now, to balance the combustion reactions of alcohol is almost the same as the hydrocarbon. You use the same trick. you look at the carbons there, you see one carbon, you put 1, that's okay. You see there are 4 hydrogens, divide by 2, so you put here 2. Now you add the oxygen on your right. I have 2 and 2, 4 oxygen. For alcohol, since you have 4 oxygen, subtract 1, then divide by 2. So it's basically 4 minus 1, then divide by 2. That's 3 by 2, or 1.5. 1.5 into 2 is 3, 3 plus 1 is 4. So the oxygen 4 here, it's all balanced. Remember, for hydrocarbons, we just divide this by 2. For alcohol, add oxygen, subtract 1, then divide by 2. Why don't you try this equation yourself? If you had tried, this is your answer. You see there are 2 carbons here, you put here 2. You see there are 6 hydrogens there. So just divide by 2, and that's 3. Check the oxygen, that's 4, and that's 3. 7. 7 minus 1 divided by 2. That's basically 6 divided by 2, which is 3. So that's how you put here 3. So that's how you do the alcohol combustion equations. Second set of equations shown by alcohols is something called as oxidation equations. Let's have a look at oxidation of alcohol. Oxidation of alcohol is a very, very important question, usually comes in the exam. It's a very popular question in the IGCSE. Now, to oxidize alcohol, the recommended oxidizing agent is potassium dichromate. That's K2Cr2O7. It must be acidified, so it must contain acid. You can write H plus aqueous, or you can write H2SO4 aqueous, and you need to heat it. So these are the conditions for oxidation. That's your oxidizing agent. It's orange in color, changes to green. It must be acidified. Sulfuric acid is best there, and you heat it. So under these conditions, the alcohols get oxidized to carboxylic acid. Only in your senior classes, when you study different kinds of alcohol, then you will find different kinds of compounds, what you'll get. But as of now, in IGCSE, you only deal with what is called as a primary alcohol. So you only work with them. So let's have a look at a very simple few alcohols there. CH3OH, or could be C2H5OH, or C3H7OH. So let's have a look at 3 alcohols. And what we're trying to do is we're trying to do the oxidation of alcohols. Now remember, when you oxidize alcohols, you write the oxygen there, but it's very tempting for students to misunderstand that this could be a combustion equation. But then this is not a combustion equation, it's an oxidation equation because we have an oxidizing agent there. Now the star point here is the alcohols, they get oxidized to carboxylic acid with the same number of carbon atoms. Now I see there is only 1 carbon atom here, that's methanol. It has to change to methanoic acid, that's the carboxylic acid. Now the carboxylic acid has this functional group, COOH. Now this methanol has to change to a carboxylic acid, which is COOH, but then there's an empty bond here. I can't leave it empty, so it has to be an H, plus I get water. So methanol changes to methanoic acid. So what do you think will happen to ethanol? What is your guess? Ethanol will change to ethanoic acid. Propanol will change to propanoic acid. So why don't you try? Ethanoic acid means 2 carbons. So write your 2 carbons. Remember, the carbon here is COOH, that's the carboxylic group. This carbon has 1 bond, so it needs 3 more, CH3 plus H2O. So what about this one? It has 3 carbons. So put here 3 carbons. This is COOH. The first has to be CH3. That's a CH2 plus H2O. So propanol changes to propanoic acid. Don't forget, in all these equations, the orange color of potassium dichromate will change to green. So that's the oxidizing agent. Every oxidizing agent gets reduced, and therefore these alcohols are getting oxidized. So they're kind of acting as a reducing agent for the potassium dichromate. So that's the oxidation reactions of alcohol. Alcohols also undergo something called as dehydration. Now, it would be good if you could remember when you add steam to alkene, you got alcohol. So when you remove water out of alcohol, you get the alkene back. That's basically what dehydration is. So the best dehydrating agent is H2SO4 liquid at 170 degrees Celsius. That's the dehydrating agent. Don't forget, if you write aqueous, you will lose the mark. It has to be liquid, it's concentrated. Dilute sulfuric acid cannot work. So if you have these conditions, the alcohol can lose the water. Now for example, I have here ethanol. Pardon me. I have an ethanol, and let's say if I react ethanol with this H2SO4 liquid in 170, this carbon here will lose the OH group. This carbon here will lose the H. Same carbon cannot lose H and OH. So OH will go from there, H will go from there. So which means, in fact, if I use display formula, it will be easy for you. That's CH3, that is CH2OH. Okay, so remember, this carbon will lose the OH, and this carbon here will lose any one of these H's. So I'm removing this H here. So what is left is carbon with two H's. That's a single covalent bond. There's one H is left, this one H is left. See, that OH is gone and this is gone. So what do you think should happen here? 1, 2, 3. That's not right. Carbon should have 4 bonds. That's how we get the ethene plus H2O. So if you remember, ethene plus steam gives you ethanol. Now ethanol, you remove water out, you get the ethene back. Let's try another reaction. Same condition. Let's try for CH3, CH2, CHOH, CH3. Okay, would you like to name this alcohol? I have 4 carbons there, so that's butane, that's OH, that's definitely butanol, and I have to number from this side, so it's basically to be known as butane 2-ol. Now let's have a look. We are going to do dehydration. It means carbon number 2 will lose the OH. Now in IGCSE, you basically have a choice. You could remove H from carbon number 1, or you could remove from carbon number 3. Only in AS classes, again, you will study some more detailed rules as to what is the major product and minor product. But as of now, you could do whatever you want. The examiners will still give you a mark. Preferably, you should remove carbon H from the carbon who has less H. So preferably, remove H from here. Which means this carbon has 3 H's. This carbon has only 1 H. This carbon has only 1 H. And this carbon has 3 H's. So what do you think should happen here now? Because one OH went out, one H went out, so there's a double bond here. There. So that's basically but-2-ene. That's how we do dehydration for alcohols. And the last reaction for alcohol is a very, very important reaction for the examinations called esterification. This is a very, very popular examination question that you will get to see in the past papers. Now in esterification reaction, it's a reaction between a carboxylic acid and an alcohol to form ester and water. This reaction takes place in the presence of concentrate H2SO4 as catalyst, and it also needs heat. So let's have a look. Let's have a look at any carboxylic acid of your choice. So I'm starting off with ethanoic acid. Now remember, ethanoic acid has 2 carbons. So that's 2 carbons there. That's ethanoic acid. And let's say I want to react this with methanol. So CH3OH, methanol. It's a reversible reaction there. Now when you do esterification reaction, it's easy to understand if you follow, if you just remember the simple tricks. From carboxylic, remove the OH. From the alcohol, remove the H. And you go this way and you go this way. You just basically swipe the alcohol the other way around. So what you get is CH3, C double bond O, and you just basically turn the alcohol this way. So you have O, and then they have a carbon, and it has 3 CH3s. So this is your ester, plus you get H2O. That's because you remove the H and the OH. So that's the ester link that you see here. And how do we name an ester? There are two ways to learn it quickly. Traditionally, remember, this part has come from the alcohol. So that's the methyl. This is the methyl. This is the ethanoate. So methyl ethanoate. That's the first word of the ester names come from the alcohol is methanol. So the first word of the ester would be methyl. This is ethanoic acid. So the second word of the ester is ethanoate. So methyl ethanoate. See, there are 2 carbons there. That's the ethanoate. And there's 1 carbon here. That's the methyl. Let's practice one more. Let's have a look. This time, let's have a look at propanoic acid and ethanol. Now, propanoic acid will have 3 carbons. CH3, CH2, COOH. Ethanol, CH3, CH2OH. It's a reversible reaction. So, from the carboxylic acid, remove this. From the alcohol, remove this. Go this way, go this way. So, what is left is CH3, CH2, CO, and then you come here and go this way. So, it's O, and then you have this carbon, CH2, then you have this carbon, CH3 plus H2O. There you go, that's the ester. Why don't you try to name it? Remember, when you name the ester, just cut it here. This part is the one which has come from the ethanol. This is ethyl. So we name this as ethyl. And this part has come from the carboxylic acid. It has 3 carbons there. So that's propanoate. That's basically how we distinguish the ester. So that's it. That's for today. I have tried to go through some basic essential reactions of the IGCSE chemistry. We went through alkanes, alkenes, alcohols. We did combustion, oxidation, dehydration, and esterification of the alcohol. These are all the backbone equations what you have to know in topic 14 of your syllabus of IGCSE. Remember, practice is the key. I have given you some examples. Why don't you add some more examples of your choice so that you become more and more strong in the naming and the structures. Also pay attention to condensation, polymerization, and the earlier part of the lesson which talks about isomerism and general properties of definitions of homologous and functional groups and so on. Practice much on simple structures. That's the key to organic chemistry, how strong you are to draw the structures and to name it. I will be trying to make a video very soon of the other aspects of the IGCSE chemistry. I hope you liked my presentation. And if you like it, don't forget to subscribe and click the like button. And I'll see you again. Take care.